Hello everyone, this is Dr. Prashant and welcome back to Biostatistics lecture series. In this video, we will discuss about the statistical tests. To start with the introduction, the type of statistical test depends on the following factors. 1. What are the aims and objectives of your study? And what is the hypothesis to be tested? And what type of data is the outcome data, whether it's continuous or categorical? How is the outcome data distributed and what are the summary measures used? To start with the continuous outcomes, if you want to compare two groups of paired observations, what does it mean? Paired data may arise when the same individuals are studied more than once, usually in different circumstances, or when individuals are paired as in case control study. Let's understand this with a simple example. As part of leg ulcer trial, data were collected on health related quality of life at baseline, 3 months and 12 months follow-up. We may be interested in seeing if there is change in health related quality of life between baseline and 3 months follow-up. So let's understand the question. First, we need to identify what type of data it is, what type of outcome data it is. So health related quality of life at baseline and 3 months are both continuous variables, okay? And data are paired. Why I'm using the word paired? Because measurements are made on the same individuals but at different points of time, right? At baseline and 3 months. Therefore, interest is in the mean of the differences and not the difference between the two means, because we are taking measurements on the same individuals but at different times. So the most common test used in this case where comparison of two groups that are paired, that is paired t-test. And what are the assumptions of paired t-test? If the differences is normally distributing and differences are independent of each other. And now coming to comparison of two independent groups, what does it mean? In this case, there are two different groups. Taking the same example, in the same leg ulcer trial, was whether there was a difference in the number of ulcer-free weeks between the intervention and control groups. So here we are trying to ask whether there is a difference in number of ulcer-free weeks. What does it mean? Number of ulcer-free weeks is a continuous data, right? So number of ulcer-free weeks is continuous data and there are two independent groups because we are not taking measurements on the same group, okay? There is intervention group and there is control group. So the most common test used in this case is independent two-sample t-test for comparing means. The independent sample t-test is used to test for a difference in the mean value of a continuous variable between two groups. So what are the assumptions of independent two-sample t-test? The groups are independent because there are two different groups and the variables of interest are continuous. And the data in both groups have similar standard deviations and the data is normally distributed in both groups. And now if you want to compare more than two groups and the data is continuous type. So in the first case, we took measurements on the same individuals but at different points of time, right? And in the second case, there are two independent groups. So we used independent t-test. But in this case, if you want to compare more than two groups and the type of outcome data is continuous, we use ANOVA. So ANOVA is nothing but analysis of variance. It is an analogous method for independent samples t-test having more than two groups and the assumptions are similar to that of independent t-test. So let's understand this with an example. A study is designed to test whether there is a difference in mean daily calcium intake in adults with normal bone density, adults with osteopenia and adults with osteoporosis. So there are three different groups, right? Normal, osteopenia and osteoporosis. Adults 60 years of age with normal bone density, osteopenia and osteoporosis are selected at random from hospital records and invited to participate in the study. Each participant's daily calcium intake is measured based on reported food intake and supplements. So let's break down the question. First, identify the outcome. So in this case, if you can clearly see what they're measuring daily calcium intake. So it is a continuous variable, okay? And how many groups are there in this case? It's more than two groups, right? Normal, osteopenia and osteoporosis patients. So multiple groups, more than two groups and the data, outcome data is continuous. So we use ANOVA. And now coming to categorical outcomes, similar to that of continuous outcomes, comparison of two independent groups, okay? But the outcome data is categorical. So let's understand with an example. In the same leg ulcer trial, we may wish to know whether there was a difference between the groups in the proportions with healed ulcers at 3 months follow-up. So what does it mean? There are two independent groups, intervention and control, and a binary variable, ulcer healed versus not healed. So in this case, we just want to see whether the ulcer was healed or not. It's a kind of yes or no type of question. So if you go back to the basics, if you remember the qualitative data, right, nominal data, so I have already discussed about the binary data. It can take only two values. So in this case, it is ulcer healed versus not healed. We'll just see whether it's got healed or not healed rather than the continuous outcome. So the best comparative summary measure is the difference in proportions healed between the two groups. So as per the question, they just want to know whether it got healed or not. So the type of data is categorical data. And how many groups are there? There are two independent groups. What are they? One is control and other is intervention group. So in this case, we use two methods. One is cross tabulation, which is used to examine the relation between two categorical variables. And the other is chi-square test, where we test the null hypothesis. So let's see a simple example of cross tabulation and chi-square. So the first table is the example of cross tabulation. Okay, the outcome variable is categorical in this case because we are going to see whether the neonatal complications are present or absent. Similarly, if you see the chi-square test, we run the chi-square test for what? To test the hypothesis. Okay, if you can see in this test, the p-value is around 0.023. So based on this p-value, we will see whether to reject or not reject the null hypothesis that we have already discussed in the concept of p-value, right? And now coming to comparison of two groups of paired observations, and the outcome data is categorical. So when do we use it? In case of crossover clinical trials and matched pair case control studies, similar to that of what we have seen in continuous outcomes. So let's say an example. There was a study, it is a matched case control study in which the controls were men from the same hospital, whereas cases are those who are suffering from testicular cancer. Okay, so what they have done, they just want to see whether their testes were descended at birth. So what type of question is this? Let's understand it. It's a type of yes or no type of question, right? So it's a categorical outcome. So categorical outcome, and they are paired because it's a matched case control study. But if you want to see some relation between two or more continuous variables, okay, and if you want to see some relation, there are two methods. One is correlation and other is regression. Correlation is nothing but a simple linear association between the two variables. The strength of association is summarized by the correlation coefficient. So now coming to regression, if you want to see the dependence of one variable, that is the dependent variable, on another, that is the independent variable, we use regression. The relationship is summarized by a regression equation consisting of a slope and an intercept. In linear regression, the dependent variable is continuous, whereas in logistic regression, it is binary. In multiple regression, we are interested in the simultaneous relationship between one dependent variable and number of independent variables. So I will explain them with clear examples so that you will get a better idea. So this is the regression line equation, and that equation will be in the form of y equal to a plus bx, where x is the explanatory variable, y is the dependent variable, and the slope of line is b, a is the intercept or the value of y when x equal to 0. So if you see an example, weight in kgs equal to 14.5 plus 100 multiplied by height in meters. So this is in the form of y equal to a plus bx. So what is y? Y is a dependent variable, that is weight, whereas a equal to intercept, that is 14.5, and b is the slope of the line, that is 100. And what is x? X is the explanatory variable, or we can call it as independent variable, that is height in this case. So how do you interpret it? If you increase height by 1 meter, weight increases by an average of 100 kgs. So that is how you interpret the regression line equation. So now let's see some examples, and just to understand how to identify what type of test to be used in the particular scenario. So in the first example, the first thing you need to identify is the what type of outcome variable it is. Okay, so I have just highlighted those points. First you see the groups. It was mentioned 3 comparison treatments. Okay, 3 comparison treatment, it is nothing but more than 2 groups. That is clear. And if you see what they are measuring, what is the outcome? That is systolic blood pressure. So it is continuous variable. Blood pressure is nothing but 120, 130 mm of Hg. Quantitative continuous. So systolic blood pressure, that is continuous, and there are more than 2 groups. What test we use? We use ANOVA in this case. Similarly, in the second question, total cholesterol level is measured. Okay, so what is that? It is a continuous variable, quantitative measurement, right? And let's see how many groups are there. There is only one sample. Okay, so we use one sample t-test in this case. Similarly, in the third question, birth weights in grams are measured for 20 male and 20 female. So there are two independent groups. One is male and other is female. That is clear. And what is the measurement in this case? Birth weights in grams. So it is a quantitative continuous measurement. So we use independent two sample t-test. Similarly, in the fourth question, if you see, the outcome data is a categorical outcome. Okay. So categorical outcome, and there are two groups. So what are the two groups? There are two different treatment groups, right? They got treated with different drugs. So two different groups, two independent groups, and the outcome is categorical. So we use crosstabs and chi-square test. So in the last question, if you want to see the relation between two variables, that is hemoglobin level and age. So first identify what type of variables are there. HB level, it is a continuous variable. Age is also a continuous variable. So if you want to find relation between two continuous variables, we use linear regression in this case. Similarly, if you want to see the relation between mean HP level of women with any given packet cell volume and age. So just see how many independent variables are there in this case. There are two independent variables. One is PCV and the other is age. And how many dependent variables are there? There is one dependent variable, that is mean HP level. So if you want to see relation between one dependent variable and multiple independent variables, we use multiple regression. Thank you.